Good morning. Yesterday we started 10.3, which was the quotient of powers property, and we talked about how when you are dividing powers with the same base, you would subtract your exponents. And I did an example on the previous video of simplifying an expression and writing your answer as a power, meaning your answer is going to be showing a base and an exponent. I'm going to do one more example of that, and then we're going to do an example of simplifying an expression as far as we can. So your answer won't necessarily be as a power. However, it may be if there are variables involved, but if you have an actual number raised to a power, then you would have to solve that through. Okay, so I just wanted to show you, for example, if we have a to the power of 10 divided by a to the power of 6 multiplied by a to the power of 7 divided by a to the power of 4. Now there's two ways you can do this. You could actually multiply your numerators together and put that over your denominators multiplied together and then do the division. Or you can divide, and then multiply. So either one works. So I'll show you both ways. So the first way, I'm going to go ahead and multiply my a to the 10th power times my a to the 7th power. So this is going to be a 10 plus 7 over a 6 plus 4. And then I get a to the power of 17 over a to the power of 10. Now I'm dividing with the same base, so that's going to be a 17 minus 10, which equals a to the 7th power. Okay? If I do it the other way, so now I'm going to divide this first, then I'm going to multiply what I get from dividing this. So a to the 10th power divided by a to the 6th power would be a 10 minus 6 multiplied by a 7 minus 4, which would give me a to the 4th power times a to the 3rd power. Now I'm multiplying with the same base, so I add my exponents. A to the 4 plus 3 equals a to the 7th power. So either way works. You can divide first, or you can multiply first, or you can switch it. You will get the same answer as long as you are following the rules of the property. Okay? So now let's simplify expressions where our answer is not necessarily written as a power. Okay, I'm going to do one that's in the textbook. Now this is going to look a little crazy, but just follow the rules. 5 to the power of 12 times c to the power of 10 times d squared divided by 5 to the power of 9 times c to the power of 9. Okay, so it looks like a lot. Let me just fix this so this looks like a 10. Okay. And what you're doing here, just kind of like in this example, okay, I could write it this way where there's two separate fractions, or I could have actually made my division bar go across the whole thing and just put a to the 10th power times a to the 7th over. Okay, so it's kind of the same thing down here. It's already all put together. However, I can separate this. I can put my bases of 5s together, and I can put my bases of c together. So I can rewrite this as 5 to the power of 12 over 5 to the power of 9 times c to the power of 10 over c to the power of 9 times d squared. So now I can go ahead and solve. 5 to the power of 12 divided by 5 to the power of 9 is 5 to the power of 12 minus 9. C to the power of 10 divided by c to the power of 9 is c to the power of 10 minus 9 times d squared. Okay, still going. 5 to the power of 12 minus 9 is 5 to the power of 3 times c to the power of 1, which anything to the power of 1 is just itself. So c to the power of 1 is c times d squared. And now I need to actually solve what 5 to the power of 3 is. I can't leave it like that. When I'm if your problem is asking you to simplify your expression and it does not state the part where it says write your answer as a power, then you need to keep going. So 5 cubed, or 5 to the power of 3, is 5 times 5 times 5, which is 125. And now, since I'm multiplying, I'm just going to put it all together. 125 times c times d squared. Okay? You're just going through the steps. Don't try and skip a step. I'm going to go ahead and leave that here. If you would like to, if you're confused while you're doing your assignment for today and you would like to hop on Google Meets and just send me a message and I can work through the problem with you until you feel comfortable. All right? Have a great day.